All right, so we're going to be continuing on now with example D. All right, so we're going to be pulling from a little bit of geometry. And so we're given that the volume of a sphere is 4/3 times pi r cubed. I know that you guys all had that memorized, and you guys probably go over geometry formulas all the time, like in your sleep. That's really cool. So you guys probably know that one. And anyways, so what we want to do right now is we want to find the domain of this. Okay, and if we go back to my secret question, okay, look at my special question I have up here. What values make what x values make the function undefined? Meaning like it's not possible. So in this case, it's not going to be x, it's going to be r, right? So what values will make this undefined? What values can you not plug in for r right here, okay? So if you have a sphere, okay, this is the best that I do. Please don't laugh. All right, I'm not the best artist here, okay? This is a sphere, little cool shadow right here, okay? It's a good little thing going on there, okay, like that. So, and then our r starts from the middle, and then it goes out to the end, and that's our r right there, right? So we want to know what values can r never be, and then that's going to be your domain. It'll be all values except blah blah blah. Let's think about this. A sphere can't have r can't be 0. This makes sense, right? I mean, how do you have a sphere that has a radius of 0? That means it's not even a sphere anymore. It's just a dot. It's a place in the plane, right? I mean, it's not even anything. Or how about if r is like -1? Have you ever seen -1 radius? Oh, look at my pencil with the dimensions of -1 feet. Oh yeah. What the heck is -1, right? I mean, we can't have negative distance. So r -2, it can't be that. R can't be -3. So hopefully, do you see here that r has to be bigger than 0? So the way that we can write our domain is we can say that it's all real numbers except where r has to be bigger than 0. That would be our domain. And you can also write that, let's see what's another way that we can write this. We can say the domain is all values of r such that r is greater than 0. That's another way of writing that. Okay, so, and then one more way is you can write r, r has to, it's actually, that's it right there probably. All right, good, then, so that would be the answer right there. The domain is all values of r except all negative and all values of 0, because you can't, it's not possible to have a radius like that. Okay, so hopefully my little question of what makes it undefined is helping you. You just ask yourself that question: what value will make it undefined, not possible? That's really the trick to find the domain of any function here. Let's go to E now. So we're given k of x, so some function named k, to the square root of 4 minus 3x. Okay, we'll graph this after we're done doing this algebraically. And so let's think about this. Think about any x value that you input right here. Okay, can you think of any value of x that would make this undefined, not possible? You're a trick me, Mr. McCaffrey. You trick me. Well, let's just think of a square root in general. What number can you not put in there? You learned this from Algebra 1 and also in Algebra 2. You can't put any what kind of values in there? You can't put any negative values, right? You can't put any negative. Because if you put a negative, then you're going to get I or complex numbers. But we're not talking about complex roots and complex numbers right now, only real values. So we want to know all the values of x where the only values that this can be is what? Where these are greater than 0, right? As long as whatever's inside of the square root, as long as it's bigger than 0, we are cool. We're down. We're home dogs. We're like, yo, BFFs, all over my Facebook, you know, tweeting all day long, right? So that's what we're going to do here. So we want to find all the values of x here. So I'm going to subtract 4. So negative 3x is greater than negative 4. And then I divide by negative 3, which means I have to flip my inequality, rule from Algebra 1. Anytime you divide or multiply by a negative, you flip your inequality. So 4/3. So as long as x is less than 4/3, as long as x is less than 4/3, then you're cool. And again, 4/3 is the same thing as like 1.33 with the bar on there. So we're saying that x has to be less than 1/3. It has to be. Really? Does it really have to be? Okay, fine. Well, let's see. Pick a number that's bigger than 1.33. How about 2? So watch this. Say if x is 2. Watch. I'm going to show you that you can't pick 2. Square root of 4 minus 3 times 2. 4 minus 6, negative 2. Right? You can't take the square root of a negative. So as long as your x value that you choose is less than 4/3, it's always going to give you a positive value. So our domain will be all real values, except where x, oh, I'm sorry, not equal to, where x is, what do we say, less than 4/3. Okay, so this is what we want to say right here. Okay, let's just graph this so that it can kind of make sense, and then we will finally be done. Let me pull this guy up over here. This is my little space. And there it is. It pops up. Oops. And cool. Get this guy lined up here. Sorry, should have had that ready to go. Cool. So the square roots, 4 minus 3x, right? Oh, hold on. I don't want to do that, though. Even though that's a cool feature that it does, and lets you do it transparent. So I just graphed this. Now look here. The graph goes, and then it stops right there. I wonder what that number is. I wonder, well, let me just zoom in. Let me just do a little zoomy action right now. If I zoom in, I just really wonder what this number is right here. I'm just so curious. I wonder if maybe if we already know it. Oh, 1.3. Where did that number come from right there? Watch this. If I go to second, calculate. And I say calculate a value, meaning let's plug in 4/3. If you plug in 4/3, wasn't this the value that x cannot be any bigger than, right? That's 4/3. So that means if you pick a number bigger than 4/3, notice, look at the graph. It stops because it's not possible. You can't graph it out here. So if you look at this graphically, it should make sense. Oh, that's why it has to be bigger than 4/3, because when you look at the graph, it graphs cool, but then once you get to 4/3, it stops. Hopefully that makes a little sense right there. Cool beans.